Good afternoon, everyone. We are a team from Iowa State University. Our project proposal is for improving the communication of work zone data. Work zones are areas where there is a construction or a maintenance activity occurring on the roadway. They're critical to the roadway system and they impact it in terms of its safety and mobility. Work zones are known to account for 10% of the congestion on roadways. In terms of safety, recent studies have shown that 20,000 workers have been injured every year in duty, which translates to one worker in every 14 minutes. When we look at fatality reports, just this year, 61 names have been added to the National Work Zone Memorial, which is memorializing people who've lost their life in work in these work zones. What these numbers show us is the severity of the safety and how it needs to be addressed quickly. So what we propose to do is to collect data, to use the data that's available from work zone and manage it in an efficient way so that it can translate to improving the safety and mobility across the work zones. So we are focusing on the maintenance operation. Currently, a maintenance operator has to call in to a traffic management center to report information such as the maintenance activity, the start of the activity, the end of the activity, information on the road conditions, and about the lane closures. Even a slight change in any of these data fields, they'll have to manually make another call to report that change. What we propose to do is use the GPS-enabled trucks which are deployed on the roadways to automate all of this information so that we can drastically reduce their manual labor. We hope that this will in turn also improve their safety as they work in field. Currently, we're looking at the DOT deploying different equipment to make sure that the information is relayed to the traveler. In future, we're hoping that this information can be given to the traveler within the vehicle environment even before they move into a work, so they can be better prepared. In the process of this study, we have identified the stakeholders as the maintenance field staff, the TMC operators, and the DOT staff who will be handling this data on a daily basis. An external stakeholder would be the public or the third-party navigation apps or connected vehicles who would be using this information to help them plan their travel better.
Let's go through an example. Imagine a slow-moving work zone which is going from point A to point B. What happens now is a worker calls TMC and says both of these roads will be closed for the entire day. But is it really necessary to report that Lincoln Way is closed while they are working on Campus Avenue? Or when they are done on Campus Avenue and go to Lincoln Way, is it necessary to report that Campus Avenue is closed? For sure not, but nobody is updating the TMC continuously. Let's compare the maps versus reality. It happens to all of us when we see that the map says there is a work zone ahead, but when we arrive on the road, actually there is nothing there. So why it happens? Have you thought about that? Maybe the work zone finished sooner than what was expected, or maybe due to weather condition, the workers stopped the work zone, but they forgot to update the TMC. So it happens to all of us. But what other alternative sources do we have to update the work zone location? We have more than 800 trucks statewide equipped with GPS devices, and they are sending pings every 6 seconds to DOT with their exact location and the speed of the truck. So let's do a small comparison. For the manual entry, which a worker does, it's not accurate, it's costly because we have to pay, it has human error, maybe they reported 20 miles for a work zone where the actual work zone is only 1 mile. And for sure, it's not real time because they are not continuously calling TMC and updating them. But what about a maintenance truck equipped with GPS? The data that comes from that is accurate. We have already the trucks equipped with GPS, so there is no more cost. For the location is exactly precise, and for sure it's real time because every 6 seconds they send us an update. So let's face the reality. Sometimes the humans are not the best option. So let's change the source from human being to maintenance truck equipped with GPS for work zone location update.
Let us go through the solution requirements. The first one is to minimize the need of data input by workers. The second one would be to automate the entire process of identifying slow-moving maintenance activity. The third one would be to automate the association of the truck GPS data to advanced traffic management system events. And also finally provide the data in a format that can be consumed by third-party systems. So we have a three-step solution to this problem. One is to conflate the data to a linear referencing system. By doing so, we are basically taking it out of the spatial coordinate system into a format where it is easily integratable with any data source. Second is clustering. So we have two types of clustering happening here. One is temporal clustering, where we do 1 minute aggregate of the data points. The second is a spatial clustering, where data points that are in close proximity, that is within a buffer range, are grouped together as a single activity. As you can see on the right hand side, where all those pings are grouped together as a single maintenance activity. So we're trying to be able to pinpoint the exact extent of the work zone activity, and this is possible by integrating the truck GPS data with the ATMS data, and LRS is helping us do that. As you can see on the right hand side, the extent of the work zone activity reported by our feed is much more accurate than that reported by the workers on the site. ATMS provides extra details like end time, number of lanes closed, and so many other things, which is why we're integrating the two sources together. Next, we will see the architecture. Now, with over 800 trucks pinging every 6 seconds, we're talking about a lot of data in the nature of big data. So we started thinking of a scalable and robust architecture solution, a hybrid solution in fact, where actually the data would be taken from IODT API and stored on a database on the cloud. Periodically, we would pull it into the Hadoop cluster, which is housed on premise, and further processing of the data happens between the Hadoop cluster and PostgreSQL database, both on premise. Finally, the data is made available to the front end. Now we will see a more granular level architecture diagram. So as you can see, the data ingestion module brings in the data from the external source into our hardware system on premise. The processing unit basically pre-processes the data and does the LRS conflation. The clustering and tracking module basically helps with the temporospatial clustering, which we discussed earlier. And finally, the data is made available to the front end for visualization through Tableau, and also as an external data feed, which is in conformity with the work zone data exchange standards.
Let's discuss the level of effort to implement. So this is the estimated cost for 3 years of service, and it's under the assumption that all the equipment stays out the same in the field and no changes have been made to the maintenance vehicles, and what we believe would be the cost to get our service up and running. Moving on to the benefits and impacts. In developing an automated process for work zone management, we have leveraged existing data sources of the GPS modules on maintenance trucks. This is going to reduce our operational complexity as no new infrastructure needs to be built. Also, by providing the results in a work zone data exchange format to third-party consumers and the public, we are giving them access to accurate work zone location and timing and the ability to dynamically track them. This contributes to safety as it is improving traffic flow and reducing congestion. Beyond commuter safety, we are also focusing on worker safety. Since we are no longer dependent on them to provide consistent updates to the traffic management centers, they can focus on their safety in work zones. Along with the safety, operational, and mobility benefit, the environmental benefit over here is it is reducing emissions and reducing fuel consumption. In summary, we know that work zones are crucial towards a healthy road system, and it becomes vital that we are able to effectively and efficiently monitor and track them. Towards this, we have proposed and demonstrated an automated process, which is capable of leveraging existing maintenance truck GPS systems and automatically collect information out of them, use this information to identify and dynamically track work zones, and provide the results to third-party vendors and public in the work zone data exchange format, thus in overall contributing to improved communication in work zones. Thank you.